Okay, we're going to go ahead and take a look at the beginning part of section 5.2 for Math 110. This is binomial probability distribution. It says experiments in which only two outcomes are possible are referred to as a binomial experiment, provided that certain criteria is met. So we need to know this. Give that a star. This is an experiment said to be a binomial experiment if these four things are met. So the first one is that the experiment is going to be performed a fixed number of times. And we call each one a trial. It says the trials are going to be independent. This means that one has no effect on the other. For each trial, there are two disjoint or mutually exclusive outcomes. So we call them success or failure. The probability of a success is going to be the same for each trial of the experiment. It says, let the random variable x be the number of successes in n trials of the binomial experiment, then x is called the binomial random variable. Notation used for the binomial probability distribution. So there's going to be n independent trials of the experiment. P denotes the probability of success. 1 minus p, which we also call q, is the probability of failure for each trial, and x denotes the number of successes in n independent trials and experiments. So you can say that x is between 0 and n. So there are a few examples here, 3 parts. It says determine which of the following probability experiments represents a binomial experiment if the probability experiment is not binomial, state why. So in order for these to be binomial, all 4 of those conditions that are up here have to be met. If any one of them does not have something met, then we can say that it is not binomial. So again, pause the video and see if you can answer those on your own. Okay, so the first one says, an experimental drug is administered to 100 randomly selected individuals with the number of individuals responding favorably recorded. So we have 100 trials, and with those 100 trials, we are dealing with people, so they are independent. And there's 2 things that are happening here. They're either going to be favorably responded or not favorable. So we'll say favorable or not favorable. And I'm going to say that the probability for each person would be the same. So same probability. This problem doesn't really give us that information, but usually for the problems that we are seeing on our own for homework, it would state that the probability would be equal to like 1/2 or something. So therefore, we can say that this is binomial. So this follows a binomial distribution. So the second one says a random sample of 15 college seniors is obtained, and individuals selected are asked to state their ages. Well, if you notice ages, there's not just 2 ages to pick from, so there's more than 2 outcomes. So this is not binomial. The third one says 500 randomly selected U.S. parents with at least one child under the age of 18 are surveyed and asked if they have ever spanked their child. The number of parents who have spanked their child is recorded. So again, we have 500 people, trials, and these are independent because we are dealing with people again. And they either spank or they don't spank. You can't kind of spank. And with this, we'll say that the probability of spanking would be the same for everybody. So we'll say same probability. Again, we'd usually be given to an award problem. So therefore, this is also a binomial. Okay, so moving on to the next page, on to page 6. There's another example there for you guys to go ahead and read. And this says that when an adult is randomly selected with replacements, so they're put back into the population, there is a 0.85 probability that the person knows what Twitter is based on results from a Pew Research Center survey. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. So does it provide a binomial distribution from this? So there has to be 4 things that we have to check that were listed on the previous page. The first one is we have a fixed number of trials. and we are going to survey 5 people. So there's 5 trials. Second thing is that the trials have to be independent, and they are because we are dealing with people. And there has to be 2 disjoint outcomes, and they either know what Twitter is or they don't know what Twitter is. And then number 4 has to be a fixed probability, which we actually have this time. So we can say P is equal to 0.85, and this is fixed or the same for everybody. So it says, if part B, if the procedure does result in a binomial distribution, which it does, identify the values of N, X, P, and Q. So N is our total number of trials we have, which is 5. X is the number of individuals that we are selecting, which is going to be 3, exactly know what Twitter is. Probability is going to be 0.85, which we had written up above. Q is found by taking 1 minus P, and we get 0.15. And these are the values that we're going to be using in order to use our calculator, which is listed on the next page. So definitely things we have to be able to find in each problem. So when sampling without replacements, the sample size is no more than 5% of the size of the population. We treat the individuals as being independent, even though they're actually dependent. So the next thing we have is going to be binomial probability distribution function. So go ahead and give that a star. And this is what we have. If you notice, we're using the combinations. P is our probability raised to the power of x, 1 minus P or Q, to the n minus x power, where x is going to take on all these different values. So definitely something we should know. We're going to be using the calculator later on to kind of help us out. Now, if you struggle with math, this might be a good table to kind of look at. I usually tell students just to kind of go over this on their own. We all have a different background, but this is the different meanings with these symbols that we are going to be using. And you have to have a really good understanding of what these mean. So definitely something you want to study. We'll try some examples next.